All right, this is the first of 2 lessons on quadratic equations. So a quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals 0. The first term is referred to, the term that has the x squared is referred to the quadratic term. The term with just the x to the first power is called the linear term. And the term that has an x with the power of 0 is called the constant term. So we're going to explore a few different ways to solve quadratic equations. First method is going to be solving by factoring. So when you solve by factoring, you're going to factor your polynomial. Once you have the polynomial factored, you're going to set the factors equal to 0. The solutions are your solutions to that quadratic equation. Now this is useful. This is a useful method if the quadratic equation is factorable. For example, we're going to solve this quadratic equation by factoring. So first thing you want to do is subtract k from both sides so that we have it set up in standard form of a quadratic equation, quadratic term, linear term, constant. Then if we factor that polynomial, we get k's in the front of the parentheses, and the two numbers that we can multiply to get 20 and subtract to get 1 would be 5 and 4. The linear term is negative, so our bigger number should be negative. So a -5 and a +4. The -20, the sign of the constant term lets you know whether the signs are the same or are different. If the constant term is negative, then that means both the signs are going to be different. If the constant term is positive, both the signs will be the same. So once we set each of these factors equal to 0, we get x equals -4 and x equals 5. So -4 and 5 are our solutions, which are also referred to as zeros, also referred to as the roots. All right, next example. Again, we want to get that linear term all on the same side. We want our quadratic equation set equal to 0. And then, since all 3 of those terms are divisible by 2, we're going to divide the whole thing by 2. And then we're going to factor the quadratic equation. We get x's in the front, the two numbers that we can multiply to get 24, and add to get -11 are 8 and 3. The linear term is negative, and the constant is positive, so that the positive constant tells us that both the signs are the same, and the linear term tells us what both of those signs are, so they're both going to be negative. Set both factors equal to 0, we get x equals 3, and x equals 8. We can also solve a quadratic equation by square rooting. So to do that, you're going to first isolate the x squared. Then you're going to take the square root of both sides. Now keep in mind this method is useful when the quadratic equation is missing the linear term. Alright, so in this example, first thing we want to do is add 3 to both sides. That's going to give us 25p squared equals 36. And then we're going to divide both sides by 25. That gives us p squared equals 36 over 25. And then we take the square root of both sides, which is opposite of squaring a number. Don't forget the plus and minus in front of the square root. Square root of 36 is 6. Square root of 25 is 5. So our solutions are +6 over 5 and -6 over 5. Another example. We're going to solve this one by square rooting also. So first thing we want to do is add 19 to both sides, and then divide both sides by 10. Opposite of squaring m is square rooting it. So when we square root both sides, we'll get plus and minus the square root of 12. And to simplify that radical, we're going to use a factor tree. 2 times 6 gives us 12, and then 6 can be factored to 2 and 3. Since we have a pair of 2's, we can pull out the 2 from up under the radical sign, leaving us with the simplified radical of positive 2 root 3 and negative 2 root 3. The last method that we will explore in this lesson is completing the square. So we're going to move the constant to the right side of the equation, and then we're going to complete the square by adding the square of the linear term divided by 2. We're going to add that to both sides of the equation. And then we're going to write the left side as some quantity squared. Then we're going to solve by square rooting both sides, the last method that we looked at. All right, so example 5. First thing we want to do is add 3 to both sides to move the constant over to the right side. Notice we left a little space before the equal sign. And then we take the linear term, the coefficient of the linear term, 8, and divide it by 2. 8 divided by 2 is 4. 4 squared is 16. So we're going to add 16 to both sides of the equation. And if we factored n squared minus 8n plus 16, we get n minus 4 squared. Negative 2 plus 16 is 14. And then now we're just going to revert back to the last method, solving the quadratic equation by square rooting. So we're going to square root both sides. That will give us n minus 4 is equal to the positive and negative square root of 14. And the last step is to add 4 to both sides. And our two solutions are 4 plus the square root of 14 and 4 minus the square root of 14. All right, example 6. We're going to solve this by completing the square. So first thing we're going to do is get the quadratic and linear term on one side, the constant on the other side. So if I subtracted 128 from both sides, and then I added 3x squared to both sides. Now I'm going to take half of the linear term and square it. Half of 8 is 4. 4 squared is 16. So 16 is going to complete the square. Let's back up a little bit because that quadratic term has to be 1. So we have to factor out the 3 so that that quadratic term has a coefficient of 1. When we factor out the 3, we're left with x squared plus 8 over 3x. And now we're going to take half of the 8 over 3 and square that. Half of 8 over 3 is 8 over 6. 8 over 6 can be simplified to 4 over 3. 4 over 3 squared is 16 over 9. So we're going to add 16 over 9 to both sides of the equation. All right. Whenever I add 16 over 3 to negative 128, I get negative 368 over 3. And then now I want to write the quantity inside the parentheses as a square. So whenever I factor that, I get 3 times the quantity, x squared plus 8 over 3x plus 16 over 9, as you were. Instead of what we did was we divided both sides by 3 or multiplied both sides by 1 over 3. That's how we got the negative 368 over 9 on both sides. And then we wrote that as a square. Then we could take the square root of both sides. Don't forget the plus and minus in front of the square root. And 8 over 6 simplifies to 4 over 3. So the last step is to subtract 4 over 3 from both sides. And we want to, we have the square root of 368 over the square root of 9. Square root of 9 is just 3, but we want to simplify the square root of 368. So we're going to do a factor tree. And we have a pair of 2's, so we can pull out 2 2's from up under the radical sign. And the square root of negative 1 is just I, so we're going to pull out a 4i. And then we still have 23 left up under the radical sign. All that over 3. When we subtract 4/3 from both sides, we get our answer, which is -4 plus 4i root 23 over 3, and -4 minus 4i root 23 over 23.